Hello everyone, my name is Arturo Garcia, and today I will be talking about my Thermistor sensor project for electromechanical systems. The necessary materials for this project will be number 1, circuit breadboard, 2, jumper wires, 3, USB cable, number 4, LED bulbs, 5, the thermistor, number 6, 330 ohm resistors, number 7, 10 kilo ohm resistor, 8, Arduino board, and lastly, the Arduino IDE coding software, which is downloaded into your computer to run the code for the circuit. What is a thermistor? A thermistor is a type of temperature sensor that is used to measure temperature in air, liquid, or solid mass. Usually, thermistors can be very small in size, such as the one in our project, and consist of a sensing element which can be glass or epoxy coated. Thermistors and other type of temperature sensors can be used for a variety of things. For example, they are used in our automobiles for engine temperatures, oil temperatures, and even air temperature. So the way the Arduino converts voltage to resistance is through a series of formulas. And here we have a voltage divider formula because this is the way the circuit is rearranged. So in this formula we have our Vn, which is our voltage source, and that will be the Arduino board itself, which is 5 volts, times R1, which is a 10k ohm resistor, and R2 being our thermistor. We want to know what Vout is, which is the jumper wire that connects in between the thermistor and the resistor to the Arduino board. And we do that by using the voltage divider formula. Now if we want to find the value of R2, we will just manipulate the formula to be R1 times our voltage source over the Vout that we just found, minus 1. And here it will just be a built-in function that will convert our R2 to log that is found in our Arduino. Now to convert from analog to digital, the Arduino is a 10-bit microprocessor and it has 10 bits of resolution to store the value of voltages. So that means if there's 0 volts, that means there's 0 discrete memory. And the way we would measure it is that each size is 2 to the 10, which is 1024 discrete memory. So that means it has 1024 bits of resolution to calculate voltages. So every number in between 0 and 1024 is a voltage. So since we have 5 volts from the Arduino board, that will be 1023. And instead of plugging our Vn, or 5 volts, we will plug in the 1023 to calculate our value for R2. And our Vout will be an analog source that will also be built in. After this, our temperature, we will have to find our temperature from our resistance. And we will get the values that we just solved for earlier, convert it to the log, and then find the temperature in Kelvin. C1, C2, and C3 are all given values provided by the manufacturer in Arduino, and that will find the temperature in Kelvin. Once we get the temperature in Kelvin, we will convert that temperature to Celsius, and once we get our temperature in Celsius, we will convert that temperature to find our temperature in Fahrenheit. So here we have our thermistor circuit already built, and as you can see we already have a green LED powered on, and we'll get to why that is in a second. We have our Arduino board connected to the circuit through our jumper wires, and each LED, resistor, and thermistor will have a certain input on the board, as well as the board is connected through a USB to the laptop. And the laptop has the Arduino IDE software running in the background already, and this is the code that we will upload to the board and will help our circuit function. So some basic information that the code has are some values that are needed to convert from voltage to resistance, because remember, Arduino can only read voltage, it cannot read resistance, so we will need to find resistance in order to find our temperature. In the bottom here we have our boundary conditions for this circuit, and it means that our low temperature is equal to 70 degrees and our max temperature is equal to 80 degrees Fahrenheit, and that is the temperature range that our circuit will have to function through. As we go down, we'll see some equations that are used to convert from voltage to resistance and resistance to temperature. We particularly we want our temperature in Fahrenheit, so this is an equation to get that value in Fahrenheit. Now, the main part of this code are our if statements. And so our if statement states for the first LED, it says if temperature in Fahrenheit is less than 70 degrees, then the red LED should turn on. It should have a high value. So if we go to our serial monitor, we can currently see that our temperature is 76 degrees. Now, if I were to put an ice cold Coke on the thermistor, the LED will turn red, and that is because it is reading a temperature that is less than 70. Right now it's at 58. If I take away the Coke, then the temperature will start to rise. And our next boundary condition will state that if temperature in Fahrenheit is greater than or equal to 70 degrees and temperature in Fahrenheit is less than or equal to 80 degrees, then the green light should be on. And that is why it is on right now, and it was on in the beginning of the video, because it is already measuring the ambient room temperature, and that temperature would be currently 75.43 degrees, since it is between 70 and 80. Now our last condition states if temperature in Fahrenheit is greater than 80 degrees, then the blue light should turn on, meaning that the circuit has detected a temperature higher than 80. So if we see our temperature right now, it is 76. But if we simply just pinch the thermistor, the blue light turns on and it will read a temperature of 87 degrees. And if I let go, the green light will turn back on, since it is detecting a temperature less than 80. So that's how this code and circuit work together with the thermistor in order to make the LEDs power on.